The mysteries of black holes. Black holes are one of the most fascinating yet mysterious objects that exist in the universe. They are formed by the collapse of massive stars, and their gravitational pull is so strong that not even light can escape them. When a massive star runs out of fuel, it collapses under the force of its gravity, creating a singularity, an infinitely small point of infinite density with immense gravitational forces around it. This is what we know as a black hole. Black holes are invisible, but their presence can be detected by studying the effects of their gravitational attraction on objects around them. This has allowed us to study the impacts of their immense power on the surrounding galaxies. Hello and welcome to Oz News. Please don't forget to subscribe and hit the bell icon. The centers of most galaxies are believed to contain supermassive black holes that may contain the masses of millions to billions of suns. What happens inside a black hole remains one of the greatest mysteries in physics. Some scientists believe that matter entering a black hole is completely destroyed by its intense gravitational forces. Others believe that the matter may be preserved and exist at the center of the black hole. Recent studies have shown that black holes emit radiation, referred to as Hawking radiation. This may suggest that black holes will eventually evaporate over very long periods of time. A view of the universe as the camera pulls away while zooming, revealing the many galaxies where black holes exist. The mysteries of black holes remain one of the great scientific enigmas of our time. As we continue to explore the universe, the study of black holes will continue to provide us with new discoveries and insights into the workings of the cosmos. Tell me more. Sure, here are some additional facts about black holes. Black holes come in different sizes. Stellar black holes, which are formed from the collapse of massive stars, typically have masses between 5 and 20 times that of our Sun. Supermassive black holes, which are found at the centers of galaxies, can have masses millions or even billions of times that of our Sun. Black holes have no size limit. While stellar black holes are relatively small, the sizes of supermassive black holes are limited only by their masses. They could be as large as the solar system or even larger. Black holes can influence the evolution of galaxies. Supermassive black holes at the centers of galaxies can affect the motion and distribution of stars and gas within the galaxy. This can have a profound impact on its evolution over time. Time dilation occurs near a black hole. When a spaceship approaches a black hole, time slows down for the observer on the spaceship. This means that a person on the spaceship would experience time passing more slowly than someone far away from the black hole. This phenomenon is known as time dilation. Black holes can merge. When two black holes come close to each other, they can merge into a single, larger black hole. This phenomenon can release an immense burst of gravitational waves, which can be detected on Earth. Black holes are not necessarily dangerous to us. While black holes can consume nearby matter, the vast distances between black holes means that they are generally not a danger to us. The nearest black hole is about 1,000 light years away, which is far enough that we don't need to worry about being pulled in. These are just a few examples of the fascinating properties of black holes. While much remains unknown about these mysterious objects, scientists are continuing to study them using a variety of instruments and techniques, and we can expect many more exciting discoveries in the coming years. In the census of black holes, there are basically two populations: the big, supermassive bruisers that churn away in the hearts of large galaxies, and the smaller, comparatively runty black holes that form when massive stars collapse and die. But what about the medium-sized black holes, the middleweights, the golden retrievers, the four-door sedans that are neither galactic drain nor single stellar corpse? According to some astronomers, these intermediate black holes, with masses equivalent to anywhere between 100 and 100,000 suns, should be everywhere. After all, those million solar mass galactic drains aren't just born that way. Trouble is, the middleweights are mostly missing. Decades of searching have only yielded a handful of strong candidates. Even this week's episode of Cosmos, a space-time odyssey, which dealt at length with black holes, didn't mention the missing middleweights. But whether astronomers are having a hard time finding these intermediate mass black holes because they're tricky to find, or just really, really hard to make is an open question. Black holes in general are hard to find because by definition, they don't radiate any electromagnetic radiation, says Sydney-based astrophysicist Sean Farrell. In 2008, graduate student Joanna Rodriguez spotted what's still the leading intermediate mass black hole candidate. Rodriguez, then at the Université de Toulouse, was working with Farrell and his colleagues. She was looking for lonely neutron stars and other objects that shone brightly in X-rays using the European Space Agency's XMM Newton Space Telescope. Rodriguez saw something unexpected, an object that glowed extremely brightly in X-rays, what astronomers call an ultraluminous X-ray source, or ULX. Hovering 290 million light-years away in the halo of a galaxy known as ESO 243-49, the object was perplexing for several reasons. First, this wasn't just any old super bright thing. It was ridiculously bright, more than 10 times brighter than any known ULX, and at least 100 million times brighter than the Sun. That incredible brightness suggested something very energetic and active was taking place. And the object, now called HLX-1 for hyperluminous X-ray source, wasn't in the right place. Rather than being at the heart of its galaxy, it was off in the galactic periphery. Lastly, there seemed to be a disk of hot, turbulent gas swirling around it. At first, Farrell says, he was pretty sure they'd gotten the object's location wrong. All signs pointed to HLX-1 being a massive black hole in the process of yanking material from some nearby stars, the kind of thing that should be in the heart of a galaxy rather than on the outside. But follow-up observations suggested that HLX-1 really was on the fringe, and that the superhot gas likely came from a star being ripped apart by a black hole with several hundred solar masses. In other words, the team seemed to have found an intermediate-massed black hole. Now, nearly 6 years later, HLX-1's story has gotten even weirder. New measurements suggest it's probably around 10,000 solar masses, still within the intermediate range. And in addition to that gassy disk, Hubble Space Telescope observations point to a dense population of young blue stars clustered around the black hole. The location of HLX-1 out in the halo of ESO 243-49 is a very unusual place to find young stars, Farrell says. Something would have had to trigger the formation of these stars in the recent past. That something might be the recent collision and merger of a dwarf galaxy with ESO 243-49, a dwarf galaxy whose stars were absorbed by the larger galaxy and whose heart was punted into space. That heart is HLX-1. It simultaneously clings to some of its original stars and also supports a younger population formed during the galactic merger. Mergers of dwarf galaxies with large galaxies like the Milky Way are really common, Farrell says. So if dwarfs contain central black holes, then such black holes should be deposited in the halos of large galaxies. At a meeting in the Netherlands this week, astronomer Roberto Soria of Australia's Curtin University ranked the existing IMBH candidates. At the top of his list? HLX-1. But even though HLX-1 is the strongest IMBH candidate, it isn't alone. Another candidate, M82X1, is nipping at its heels. M82X1 was second on Soria's list. In 2006, a team led by astrophysicist Philip Carrot of the University of Iowa spotted M82X1 about 11 million light-years away. Thanks for watching and see you on next video.